Okay, so here's our first video on trigonometry. So the thing with trig is that there's kind of a lot of definitions here. So our first video is going to have some of these definitions, and then we'll talk about more definitions as we go along the way, as we need them. So for now, just some basic definitions and geometric concepts here. And a lot of these might be review from geometry, if you remember back from those days. So anyway, a ray is basically just something that starts at a point, and then it goes off in any one direction, just off infinitely far like this. So that's just what a ray is, pretty much. It's sort of like a half line. So you know, a line goes infinitely far in both directions. So if you cut it off at a point somewhere, any point, let's say here, that would be, then you get a ray. Okay, so a ray can point in any direction. So that's what a ray is. So a vertex is this point right here. So this right here is the vertex. This right here is the vertex of that first ray we drew. Okay, so rays and vertices, the plural of vertex is vertices. Let's write that down. Vertices is the plural there. So rays and vertices, they kind of go together like that. So this the vertex is part of the ray. Okay, so that's a ray and vertex, and then angle. So an angle is really like the fundamental concept of trigonometry here. We'll talk a lot more about these in the next several videos. But basically an angle is formed when you have two rays that have the same vertex. So if we have one ray here and then another ray here. So we have two different rays, but they have the same vertex, so they form what's called an angle. So there's an angle here in between them like this, and there's another angle out here. Okay, so really, depending on your application, you know, you're probably only going to be focused on one of the angles. But we'll talk a lot more about that as we go along. So anyway, here's another example of an angle. So here's our vertex, ray, and ray. Okay. So another example of an angle. So there's an angle in here, and again, there's another angle out here, and we'll talk some more about that soon. Okay, so we also have a concept of an initial side and a terminal side. So you can think of angles as rotations, starting at one ray and then ending at another. Okay, so let's say if we start at this ray here, okay, and then we rotate from this ray up to this ray, okay. So then this would be the initial side right here, and then this side would be the terminal side. Okay, because the angle starts here at this ray and then rotates through up to this ray. And then likewise, we can do same kind of thing over here. Okay, so if we draw, so this arrow indicates the direction of rotation. So we started here, so this would be our initial side. And then this side over here would be the terminal. So this ray is the terminal side here. Okay, so again, you know, where you start the rotation. So if you think of angles as rotations, where you start the rotation, that's that ray that you started, that's your initial side. And then your terminal side is where you end up. Okay. So I drew these, you know, rotating this way, but you know, we also could have thought about it rotating like this. Okay, we could also think of the rotations like that. But for now, let's just take it one thing at a time here. So let's fix that. And likewise, this this rotation here, we could have thought about it as going from this initial side around like this. Okay, so the angle would be different, but the initial and terminal sides will be the same. But again, we'll talk a lot more about that as it comes up. So anyway, that's initial and terminal side. So again, initial side is where you start the rotation, terminal side is where it ends. And then we also have the concept of positive angles and negative angles. So by the way, angle is often abbreviated like this. So if you talk about positive angles and negative angles, you could say just positive angle or negative angle. Okay. So just a little angle like that with a little line through it, or a little curvy line through it. So that's the abbreviation for angle. We'll be using that a lot in the next bunch of videos. So positive angle and negative angle. Basically, we'll talk a lot more about measurements of angles in the next video, but for now, just know that positive angles are measured going counterclockwise, and negative angles, they go clockwise. So here, if we look at this first one we drew, let's look at the first one we drew. So the initial side was here, and then we drew the rotation going like this. Okay, so the rotation points up this way, and which way is this? This is the counterclockwise direction, right? So remember, a clock goes around like this, so that's the clockwise direction. but this is going counterclockwise. So this would actually be an example of a positive angle. So this right here is a positive angle. So that's a positive angle. And this right here, this is opening in the clockwise direction because that's just how we drew the rotation here. So it starts initial side here, and then it opens out this way. Okay, so that's the direction the arrow is pointing. Okay, so it's pointing in the clockwise direction. Okay, so since that's opening up clockwise, that's a negative angle. Okay, that's a negative angle. Okay, so if you're wondering, why do positive angles go counterclockwise and negative angles go clockwise, it might seem kind of strange at first. There are some reasons for that we'll talk about maybe in a different video, and we'll briefly talk about some a little bit later. But anyway, that's positive angle and negative angle. So let's come back up here. So there's also this concept of quadrants, which you might remember from geometry or algebra, or just maybe several other math classes that you might have taken. But it is an important concept for trig, so we'll review it here. So quadrants, you have your x-axis and your y-axis. Okay. So remember, the x and y-axis divide the plane into 4 quadrants. So remember that quadrant 1 is up here, and they're often talked about with capital Roman numerals. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So capital Roman numerals, and start at quadrant 1 up here, where all the points are positive, and then go counterclockwise. So 1, 2, 3, 4. So those are the quadrants there. Okay. Just a brief review of that concept from earlier math classes. So now standard position, that's also an important concept here for trig. So standard position, an angle is said to be in standard position if, so an angle is in standard position if its initial side is the positive x-axis and its vertex. So I'm out of room, so I'll erase this definition here, and we'll come back to that later. And its vertex is the origin. Is the origin, remember that's 0, 0. Okay, so that's a really important concept. So an angle is said to be in standard position if its initial side is the positive x-axis, and its vertex is the origin, 0, 0. So let's draw a picture of that real quick. So here's x-axis, y-axis. So an angle in standard position would be something like this. So the vertex is at the origin, and the initial side is the positive x-axis. So we could open up this way, and then like that. So that would be an angle in standard position, okay? Because the initial side is here, and then we open it up this way. And also, what kind of angle is this? It's a positive angle because it opens up in the counterclockwise direction. Okay. So now that we've talked about this, we'll see some other examples of angles in standard position. But I just want to point out here. So if you have an angle in standard position, it starts on the positive x-axis, and then if you open it up towards the positive y-axis, you have a positive angle. Okay, so that might make a little more sense as to why positive angles go counterclockwise, because for angles in standard position, if you start at the positive x-axis and you move towards the positive y-axis, that's going to give you a positive angle. Okay, so you have these, everything's working together positively. Okay, but if you move towards the negative, so let's draw another one. Okay, so if you have another angle in standard position, like this, so vertex at the origin, initial side on the positive x-axis, if you open up towards the negative y-axis, okay, so the negative y-axis is down here, if you open up towards that direction, that's going to give you a negative angle. Okay, so positive angle in standard position, negative angle in standard position. Now what about something like, kind of out of room here, but let's draw something over here. So let's say we have an x-axis, a y-axis, and if we put an angle, let's say, over here, and then we open it up out this way. Okay, so this is not an angle in standard position because its vertex is 0, 0, but the initial side is not on the positive x-axis. So the initial side is down here, which is not the positive x-axis. So that's not an angle in standard position. So to be an angle in standard position, you have to have vertex at the origin and the initial side has to be the positive x-axis. Okay, so like these two here. Okay, so now the last definition to talk about in this video is what's called a quadrantal angle. So let's get rid of this here. So we have a concept of a quadrantal angle. And basically what that is it's an angle, first of all, it's in standard position. So a quadrantal angle is an angle in standard position. So let's draw one like that. So x-axis, y-axis. So a quadrantal angle is in standard position and its terminal side is on one of the axes. So like this is a quadrantal angle. Okay, because its terminal side is on the positive y-axis. So quadrantal angle, let's write that down what it is. So let's say this. A quadrantal angle is an angle in standard position whose terminal side is on an axis. Okay, so remember, standard position means the vertex is at the origin, the initial side is the positive x-axis. So to be a quadrantal angle, you have to be in standard position and you also have to have a terminal side on the positive y-axis, the negative x-axis, the negative y-axis, or the positive x-axis. So that's a quadrantal angle. Let's draw a few more. So let's erase the standard position thing here. So I want to point out that these are not quadrantal angles, so they're both in standard position, which is good, but the terminal side is not on an axis, it's inside of a quadrant. Okay, so this terminal side is in the first quadrant, this terminal side is in the fourth quadrant. Okay, so the terminal sides are not on an axis, so those are not quadrantal. And this one, this angle is not even in standard position, so it doesn't make sense to talk about it being quadrantal. Or we could just say it's not quadrantal because it's not standard position. Because it is a requirement that quadrantal angles be in standard position. So anyway, let's draw a few more examples. So x-axis, y-axis. So if we want to draw another quadrantal angle, so standard position, so we got to have initial side, positive x-axis, and vertex at the origin. Now, quadrantal angles can be positive or negative. Okay, so here is another example. Okay, so I want to point out this is actually a different angle from the one we drew. So the initial side and the terminal side are the same for both these angles, right? But this one's a positive angle, this one's a negative angle. Okay, so they are actually different angles. Okay, but there are a lot of things that they have in common. We'll talk a lot more about that in later videos, but for now I just want to point out, these actually are different angles. They have different measurements. And we'll talk about measurements of angles in the next video. But for now I just want to point that out, that these are in fact different. Even though they have the same initial side, same vertex, and the same terminal side, they are different angles. And they're both quadrantal, right? So the terminal side here is on the positive y-axis. So let's draw another one real quick. So x-axis, y-axis. Standard position, so vertex at the origin, initial side on the positive x-axis, and then we can open up this way, and then our terminal side will be over here. Okay, so this is another example of a quadrantal angle. So in this case, the terminal side is on the negative x-axis. Okay, so that's another example of a quadrantal angle. So let's do one more real quick one. Just want to point out one other thing too. So x-axis, y-axis. So, all right, so let's start with this and then let's rotate. So here again, it's in standard position because the initial side is on the positive x-axis, the vertex is at the origin. Let's rotate clockwise so it's a negative angle, and we'll go all the way around one complete revolution here so that the terminal side is the same. Okay, so that's totally legitimate. It could happen. The initial side and the terminal side could be the same side. That's fine. And in this case, we went around one full revolution like this, one full rotation. But we could have, kept going and gone around 2, 3, 4 times. That's also possible. Likewise, we could have done the same thing with any of these here. Okay, so we could have, started here. Like with this one, we could have started here, went around one full revolution, and then gone back around to this side here. So that's a different angle from the one that we had drawn here previously. The measurement's going to be different, but it's still positive, okay, because it's still being rotated counterclockwise, but the terminal side is the same and it's still a quadrantal angle. Okay, likewise over here, even though the terminal side and initial side are the same thing, that's totally fine. This is a quadrantal angle because the terminal side, because first of all, it's in standard position because the initial side is the positive x-axis, the vertex is at the origin, and the terminal side is on an axis, okay, in this case the positive x-axis. All right, so that could happen. All right, so that's it for the basic definitions here. More definitions, and we'll talk about measurements of angles like degrees and radians in the next video.